Well, this might be fun for some of you. I've had this spot in this track. You can see the black arrows indicate the position of the tender when the tender died on me. And I'm trying to determine what's going on. I've went over the track, I've tested it, thought I had everything figured out. So I set my blunderbuss here at 1 amp and 15 volts for this leg. This guy's sleeping. If he takes off, I'm screwed. But in any case, I had this LED come in, and I thought, I'm going to figure this out and see what's going on. Now, it was a little tricky. It's an old tender, right? Old caboose. I wired it I just threw it together literally, but it wouldn't work. And then I realized it has to be DC. So I had to put a rectifier and a little capacitor in there. So now you're seeing, I'm saying it's 15 volts here. They're saying it's 16.2. I got a hunch he's reading high because he was high on another system. But in any case, we're tootling along, toodle-doo, toodle-doo, toodle-doo. And I get to the dead spot, or the spot where it dies. It seems to be okay. And then I go a little further. And then I go a little further. You rascal. Just 2 minutes. Oh. See that? Between those dead spots. Alive? Not alive. The capacitor stores energy. That's what it does. It's like a shock absorber or a storage bin. So it takes a while for the meter to realize the energy's been cut. The capacitor has to drain. Look at that. Almost. No, I don't like it. Okay now. Not okay. The light is an indicator immediately, okay? Then the meter tells me exactly. So I'm thinking, you know what I'm thinking? I'm thinking this piece, when it's in that position like that, it's not connecting. It's dirty or corroded or something that is not allowing this bar to connect when the switch is thrown. That's what I think's going on. So I go through this, dies out, go back, run the switch manual. Thinks about dying out. Somehow it comes back. Now it's dead. Okay. Now it's okay. Now it's dead. It's in the switch. It's in the switch. That's all I can say. I'm going to have to take it apart. But at least I used my little gizmo to verify where the problem was and why. I suppose I could have just used the light, huh? But also, as I go around, you see there, oh, look at that. What the heck? I think it's while it's on that. Well, I'll tell you what, I'm going to be using this to test my track all over. You see when the volts drop? That's a concern. It's either dirty or you've got a poor contact. We've got 16.2. We got 15 coming in, and we think it's 16.2. So, anyway, I thought I'd share that with you. It's a quick little gizmo. I'll show you the bits. I'll show you the bits as soon as I turn power off. Okay. Now, it's just wound around here, so it will sit, all right? But here's the there's the rectifier and the capacitor. The yellow is for the light and the red is for the signal. So if I put them onto the same, it'll just be on when it's on is all. And then the black is ground. Well, in here, you know, this thing isn't really conventional. So the hot is this piece here, and the ground actually comes through the base. So I just clipped it at the base and clipped it there, brought that power into, that's AC, into the rectifier, take the DC off to the meter, and that's how I hooked it up. So if I wanted to make one of these really, like as a car, I would rather get a long one. I hate to waste a lit caboose. May put it in like a work car, one of my work cars, and actually put it in a panel, like a display, so you could actually have it pushed around or push it around by hand and measure your voltage and see if you have dirt or loose contacts or poor, you know, maybe you need to bring another feed to a certain corner, something like that. Anyway, I thought that was interesting. I wanted to share it with you guys.